Um, when we summarize a data, so chapter 5 is about summarizing data sets. And when we summarize a data set, there are two measures that we must um, consider: a measure of center and a measure of spread. We're going to start off talking about measures of center. And when I think about a measure of center, the question I'm thinking about is what's typical? What is a typical value for this data set? And ultimately, what is a typical value for the population? But we'll talk about the population down the road. Um, there are three different measures of center that the authors address in chapter 5 of our textbook. The mean, which some of you are probably already familiar with, but to calculate the mean of a data set, what we do is we add up all the data values, all the values in the data set, and then we divide by the sample size. Now notice here that I have forgot to turn my pen on. So let me turn on my pen real quick. Hold on a second here. And okay, that looks good. Now notice I put two different n's. I put a lowercase n and I put an uppercase n. And what I want to remind you is that the lowercase n is the sample size and the uppercase n is the population size. And even though the chapter 5 in the textbook is really talking about samples, I like to talk about both of these things in parallel. And also, and there's a reason for that, because down the road we start talking more and more about what's referred to in statistics as inferential statistics, which means to make an inference about a population. And what I want to do is just give you a quick review about statistics. And remember, a statistic comes from a sample and is a variable. And a parameter comes from the entire population. And in statistics, the parameter is always assumed to be constant. And there's a really good reason for this, because if we thought of the parameter as being a variable, then trying to estimate it or trying to make an inference about it would be like trying to hit a moving target. So parameters are assumed to be fixed, constant. Statistics are variables. Okay. So let's start off with the mean. We'll talk about the definition of the mean. The mean of a set of n observations of a quantitative variable is simply the sum of the observation values divided by the number of observations n. So to find the mean, we add up all the observation values and divide the total by the number of observations. So for example, to find the mean age of 20 subjects in a medical study, we add up, so that here in the numerator, we're adding up those values. There's the sum. In the denominator, we're dividing by 20. Now notice, down below, there's a generalized formula. X bar, so the symbol X with a bar over the top of it, we call that, or we say that as X bar. And it's equal to the sum. Now this symbol right here that I'm trying to draw is the summation symbol. It's a Greek sigma, for S, and it's the sum of all those x values divided by lowercase n. This is a statistic. Comes from a sample. Now, at the same time, I want to talk a little bit. I want to mention the corresponding parameter value. Okay. Now, the symbol I just drew here is a Greek M, and what we say here is mu, not moo, as in a cow, the sound a cow makes, but mu. Okay. Now, mu. The difference between x bar and mu is that mu is calculated by adding up all the values in the population. So we would divide this by uppercase n. The formulas look really similar, and they are similar. But the difference is mu is a parameter. Fixed, doesn't vary. X bar is a statistic. Again, in this chapter, we're really focused on data sets and statistics, but I do like to talk about these things in parallel. Every statistic has a corresponding parameter and vice versa. Here's an example. This is the example from a previous lecture. We were talking about king salmon. And incidentally, on a side note, I happened to be driving down Highway 36 this past weekend, and I stopped in at Grizzly Creek State Park and just for a pit stop with the kids. And I just want to mention the visitor center there is quite extraordinary. I highly recommend it if you're ever in that area. Just stop in for a few minutes and check it out. They have several different mounted fish, a large king salmon and a steelhead, and many other animals. Anyway, and a mountain lion. So just thought I'd mention that. It's a really cool place. All right, so here's the example. We're going to calculate the salmon weight, or the average salmon weight. Okay, we're looking at a measure of center here, and based on this particular data set, what is a typical salmon weigh? All right. And in this example, what we're going to do is we're going to use x bar. We're going to calculate x bar, the sample mean. So what I would start off by doing is adding up all of these data values. So I take the first data value plus the next data value plus the next data value and so on. And I'm going to put plus dot dot dot. And then I would divide by the total number of data values in the data set, which in this case is 33. Now, this is not an arithmetic class. We're going to use the TI calculator, the TI-83 or 84, to calculate things like the sample mean. And there's a couple of good reasons for that. One reason is because doing arithmetic is really, in my mind, busy work. And the other reason is because the calculator really does not make arithmetic mistakes. So, if you think about adding up 33 numbers, then there's certainly opportunities for making errors, making mistakes, things like that. Okay, so let's see. I'm gonna try this again. I want to try to. All right, I guess that's as good as it gets. I thought I could put my calculator. Oh well, in any case, let me show you how to do this. So I already have that data set entered into my calculator. I did it on an earlier example, and I named the list actually King S for King Salmon. The way we would calculate the sample mean is going second, whoops, sorry, not second. I'll click second again. We go to stat, over to calculate, so I'm going to do a right arrow to calculate, and I'm going to use something known as one var stats, and this stands for one variable statistics. And the other thing I have to do is tell the calculator which particular list I'd like the one variable statistics for. So I just went to the lists, second stat to lists. I selected list kings. Notice the little L right in front of kings. And that L is necessary. That tells the calculator that this is a list. And if you go in and paste the list in from the list menu, the calculator will automatically put that little L there in front. So that's important. Now to calculate the mean, what I'm going to do is press enter. And I get a bunch of different output here. And we're going to talk about these individual pieces and parts from one bar stats as we go through the lecture. But notice the very first thing in this list is X bar, the sample mean. So the sample mean for this particular data set is 30.51. So X bar here equals 30.51 pounds. So what we would say is, based on this data set, typical salmon weighs about 30.51 pounds. Seems pretty big, but nonetheless, that is the mean of this data set. Let's take a look at another example. In this example, we're looking at Arcata real estate prices. Now, I don't actually have this particular data set in my calculator, so I'm going to have to enter it. So I'm going to have to also figure out how I can see my calculator and the data at the same time. I could have swore I did this. Let me see. Maybe if I do, there we go. Let me try. Oh, that was weird. All right, let me see. All right, I can do it this way. It's a little bit funky, but it'll work. Okay, this time I'm going to enter the data into a temporary list. I think about L1, L2, L3 through L6. Those are the built-in lists, and sometimes I use those lists kind of like as a temporary place. You know what? I changed my mind. I'm actually going to put this data into a name list because we're going to maybe come back and look at it. And also, let me show you again how to enter data into a name list. So I just press stat. I'm going to press enter again. That takes me to the data editor. Now, your calculator screen right now may look different than mine, but that's okay. That doesn't matter. I think it's good to get used to seeing your calculator being slightly different than mine anyway. What I'm going to do is insert a blank list. So remember how to do that. Remember, first of all, that to insert a blank list, my cursor needs to be all the way up to the very top row of where the lists are. And I'm just for fun, I'm going to insert a list between L1 and L2. The calculator always inserts a list to the left. There's another way to insert a blank list also in the list editor, and I'm not going to cover that. And remember, I try to stick with one way to do these things so things don't get too confusing. In any case, I got L2 highlighted. It doesn't really matter where your cursor is, as long, horizontally, as long as it's all the way up to the top. Now what I'm going to do is press second delete for insert. Notice in blue above the delete key it says INS for insert. And I'm just going to name this list real, or actually, how about A real for Arcata real estate? Maybe I'll remember what that means down the road when we come back to this, but we'll see. All right, so A real, press enter. Now I have a list named A real for Arcata real estate. Arrow down to get into the body of the list. I'm going to start to enter the data values one by one. First one is 850,000. The prices are in thousands. So let's see, 249, 175, 299.9, which would be 299,900. So all these would be times 1,000. 189, 249, 229, 399.5, 338.5, 254.9, 459, whoops, back up, I typed the wrong key, 605, 799.777, 329, 385, $499.5, $323, $464.9, $327, $385, $338.5, $223.5, $229.9, $235, $252.75, $232.5, $279, $249, $925, $459, and finally $675. Okay, so I believe I have all the data entered into my calculator. And incidentally, I'm noticing notice how in my list I have each of these has a 0.00 no matter whether or not there's actually a decimal value behind there. And I'll just point out the reason for that is because I have my decimal fixed under mode, and I'm going to actually go in and change that. So if I press mode here and go in and notice here that I'm not going to explain what all these things mean at the moment here, but basically I have a choice of either having a floating decimal or a fixed decimal on the right, and I have my decimal fixed at 2. That means the calculator is always going to put a decimal point in 2 digits, and I don't want that right now. I want it to float, so I'm going to go back and select float. Now when I go back and look at the editor, stat edit, notice that those 0.00s are gone because now the decimal just floats where it needs to be, and if there won't be a decimal point unless there is a digit after that decimal point. Okay, anyway, just a little fine point. Now remember, what I want to do here is calculate the sample mean. So again, what I could do is add up all those values by hand and divide by the total number, which I don't even know, I forgot, I think it's like 31 or 30 something, but doesn't matter because I will get all of that information when I do 1-var stats. Here's how we do 1-var stats. Press stat, arrow 1 to the right to calculate, 1-var stats, and now I have to give it the list. So I'm going to say second stat and number 7 on my calculator. Now again, you may have different lists in here, so your numbering system will be different under your lists menu here because it really depends on how many lists you have in your calculator. L1 through L6 I think are normally the ones on top. But in any case, I'm going to press a 7 now because the shortcut for the calculator, instead of arrowing down 7 times, I could just press 7. It's a shortcut. Notice the calculator puts that little L in front indicating that this is a list. Press enter. Average price from this data set is $384,198, or 384.2 is what I'm going to round it to. 384.2. All right. So X bar what did I say? Didn't I say 382.2? Okay. Let me double check that. What did I say? 382? No, 384.2. Had a feeling I had that wrong. Okay, let me fix that. Huh, weird. All right. X bar 384.2. Okay. Now, you may be, if you're a local person, or if you live in Humboldt County and you're familiar with Arcata, you might look at that real estate price and think, gee whiz, that seems awful expensive for a house, even for a house in Arcata. And that does bring us to an important concept here. The sample mean has some problems, okay? It really only works well as a measure of center when we have a data set from that has what we call symmetry, or is symmetrical or mound shaped. Um, and it actually is the sample mean, because of the additive nature of the numerators, the fact that we're adding up all these values, the sample mean has a tendency to be skewed towards those larger values. Like, for example, there's a home in this data set. There are a couple of expensive homes. There's one in there that's like $850,000. Well, when you look at some of the other smaller data values, that one is counting for like 3 or 4. Like if I look at these two data values, like 249 and 175, that one data value is more than 4 times 175. So it's going, that large value, a few of those large values in the data set are going to inflate the mean. So, and let's look at this again on the calculator, okay? And what I want to do is I want to draw a histogram of this data set. And recall histograms from chapter 4, right? Yeah, chapter 4. Let's see, I'm going to draw a histogram. So what are the 3 steps for drawing a histogram? Well, first step is to enter the data into the calculator. I've already done that. Second step is to configure the stat plot window. So that's the next thing I'm going to do. I'm going to go second, y equals. This takes me to the stat plot menu. I'm going to select plot 1. I want it turned on, so that's good. I'll leave that as is. Remember, this icon on the right here that I've just moved my cursor to is the histogram icon. So I'll press enter, and the screen changes because histograms only have one X list and no Y list. And so now I'm going to press clear, and that takes the L2 out of there, because remember, what I want to do is draw a histogram of the real estate data. So I'm going to go second, stat, takes me to the lists. A real is where I put the data, so I'm going to choose 7. Good. So now I have the stat plot window configured, and I need to do the third thing, which is configure the scale on the axis. And I do that by going to Window and setting up these values, x min, max, x scale, and so forth. So when I'm thinking about x min and x max, okay, those are the real estate prices. What I want to do is kind of what I'm going to do is scan through the data and get a sense for what the smallest data value is. And it looks like the smallest data value is 175. So I think I'm going to start this histogram at 150. And the reason for that is because I'm already thinking about x scale. I'm already thinking, I haven't done anything with x max yet, but I'm going to come down here to x scale. Remember, x scale sets up the class width. So I think what might make sense here is to have each class width be 50,000, or 50, of course, because we're truncating the numbers. And let's see, the largest data value is 850, I believe. Oh, no, wait a minute. There's a 925 in there, so I better be careful about that. So let's say, I believe if I go to 950, that'll capture that largest data value. And I'll have a nice looking histogram here. Now, the other thing I want to point out that's important is that when I think about setting the X scale, which again is in histogram terminology what we call the class width, when I'm thinking about what I'm actually doing is I'm visualizing the x-axis, and what I'm seeing is, and what I'm thinking about, let me go back to PowerPoint here for just a second so I can give you a picture of what I'm thinking about. So as I'm visualizing what this is going to look like in the calculator, I'm thinking, all right, I'm going to have an x-axis. I've decided to start that x-axis at 150. I'm counting by 50, so the next bar is going to, or the first bar is going to have lower boundary value of 150 and upper boundary value of 200, and then the next one would be 250 because the class width is 50, and so forth, and that's how that axis on the calculator will end up being scaled. And of course, on the Y scale, this is going to be the frequencies, right? So I got to think about what makes sense for frequencies. How many data values are in each class? So what I'm thinking right now is maybe 10 is going to be enough for the Y min, or maybe what I should do is start the let me go back to the calculator. Maybe what I should do is start Y min at 0. So I'm going to go down here to Y min. That's going to be the smallest value on the Y-axis. What I'm going to try is going up to 10. Now I may end up coming back in here and revising my Y max, but that's okay because the calculator can redraw these graphs so quickly it's really no big deal. And I'm going to set the Y scale at 5, which means the tick mark will be at 5 and there'll be a tick mark at 10. All right, once we have this window configured, next step is to press graph. And what we should see is a histogram. And that histogram looks pretty good to me. But what it's showing is a skewed right distribution, okay? So what I know from what I'm seeing, or what I want to take from this graph I just drew, is that really the data that I'm looking at is not a symmetric data set, okay? So in this example, what we're really seeing here is a skewed right kind of a distribution. And I did mention in a previous lecture that what ends up happening to the sample mean is it gets skewed, it gets inflated, skewed to the right, okay, when we're dealing with a skewed data set. And so, whoops, now this is not where I wanted to be. Hold on a second now. What's going on here? What happened to my median? Okay. All right, I guess I got my what happened here? I don't know. Something's going weird with PowerPoint, but that's okay. Let me come back here. All right, this is the slide I should be on. Okay, so that takes me to the median. And the median of a set of n observations, ordered from smallest to largest, is the value such that at least half of the observations are less than or equal to that value, and at least half of the observations are greater than or equal to that value. And what we say is the median is the 50th percentile. Now, to figure out what the median is, the first thing I need to do is to sort the data, okay? And so I would start with the smallest data value, okay? Which is 175, and then I would find the next one. Let's see, what is the next largest data, or the next data value if I were sorting? I think it's 189, and so forth. And I would do this, and then what I'd be looking for is that middle one here, what we call the 50th percentile. Now I'm not going to do all of that by hand, okay? Because the calculator, again, can do this for us. So what I'm going to do is go back to the calculator, okay? And if I go back to the home screen, first thing I'm going to do is just sort the data set. Now, it turns out that 1VAR stats will also calculates the median. I'll come back to that in a minute. But right now, what I'm doing an example. This is not typically how you would do the problem, but what I'm going to do is sort my real estate list, okay? And in fact, before I do that, I'm going to show you one other thing. I've developed a habit of always storing. So what I just did is I went into the list. I went second stat. I brought up list Arcata real estate, and I'm going to store that in a temporary storage place, and I'm just going to use L2. And what I just did is I've copied all of that data into L2 because L2 is the data set is the list I'm actually going to sort. Now, in this example, it probably doesn't really matter, but in other examples, it can matter. And remember, when we were talking about scatter plots, I made the point that those two lists, the X list and the Y list, are paired together in the scatter plot. So if you sorted those lists, you would destroy that pairing, and you would have very incorrect answers there. So again, just as a practice, I find it's a good idea to not sort my original list, but to go ahead and store it into a temporary list and sort the temporary list. So I'm going to go now back to stat and choose number 2, and I'm going to sort L2, which has the exact same data values in it now because that's what I did in the very first line. So it says done, so it's done that. And this time I'm just going to look at these on the home screen. Okay, so I just press second 2 for L2, enter, prints out the data set. And what you can see now is that these data values are now sorted in order, okay, in ascending order, meaning they're getting bigger and bigger and bigger. So since there are 31 data values, okay, the one in the middle is the 16th data value. That means there'll be 15 on one side and then 15 on the other. So let me demonstrate that for you. I'm going to go back to the far left here, the very first one, and I'm going to count 15 values, or actually I'm going to count 16 values to the right. So I've got 175 as the first one, 189 is the second, 223.5 is the third, 229 is the fourth, 229.9 is the fifth data value in the sorted list, 232.5 is the sixth, 235 is the seventh, 249 is the eighth, 249, another one's 9, 249, 10th, 252, 11th, 252.75 is the 11th, 254.9 is the 12th, 279 is the 13th, 299.9 is the 14th, 323 is the 15th, so 327 is the 16th, that's the middle one, 227 is the median, there are 15 data values below, 15 above, therefore 227 is the median, what we call the median, okay? So the median what is the median? I already forgot. The median is, what did we say it was? 227. All right, so the median is 227. $327. Okay, now that's a lot of hassle, but I wanted to do one example where I actually sort the data so you can see that you could calculate the data by hand by just sorting it. But I also want to show you that you can calculate the median just as easily as the mean by doing a one-bar stat. So let's redo that. I'm going to go stat, calculate, one-bar stats. Do this one more time. And this time I can just use L2. L2 has the same data in it as list A real. So there's the mean again, 384.2 approximately. And when I come down here and scroll down, now notice the down arrow means there's more information below. When it's printing out for me, there is the median, 327, just like what I figured out by sorting the data set. So the mean is 384.2 about, and the median is about 327. So you notice how 384 is bigger than the median. The median is a better measure of spread in this example because the Arcata real estate prices are a skewed right distribution. Therefore, the median is a better measure. Now, the other measure of center I want to talk about a little bit here is called the mode. And the mode of a set of observation is the most frequently occurring value. It's the value having the highest frequency among the observations. And the mode is not often used as a measure of center for quantitative data, since the most frequent value may be far from the center of the distribution. However, it is one measure that can be computed for qualitative data. So if you think about it for a minute, categorical or qualitative data, it doesn't really make sense to add those things up. So for example, in this example, we're talking about a breakdown of undergraduate enrollment by race at the University of Michigan, okay? So the variable race, okay, is a categorical or qualitative variable. So would it make sense to add white to Asian to African American to Hispanic American Indian and no category? It doesn't. What are we getting? They're not. It's nominal data, name only. Doesn't make sense. Arithmetic, mathematical calculations on this kind of data can't do it. So the mean and the median are out for this type of a data set. However, we can still talk about typical. And in this example, what we would argue by using the mode, which of course here you can see from the bar chart, white is by far the most common or the most frequent category. So we might say, or we might argue, that the typical undergraduate student at University of Michigan is white. And if we did, the statistic we would be using is the mode. All right, well, that does it for this lecture. And like I said, this is a little bit of an experiment. I hope that the quality of these videos is better. And if this works out, then I think I'm going to switch to this mode of lecturing. And this will be streaming off of a web page that I create. So we'll see how it goes. Anyhow, I hope things are going well. Send me an email if you have any questions. All right, that's Todd-Olson at redwoods.edu. Have a good day.